Hello, my name is Mark Allen, Product Manager for Mityvac, and I'm here to talk about how to properly diagnose a fuel delivery system. Because fuel pressure is so critical to modern fuel injection systems, current diagnostic techniques tend to focus only on the capability of the fuel delivery system to provide pressure. So while fuel volume is just as critical to engine performance, it is largely overlooked or assumed to be adequate. In many cases, checking fuel volume is considered only as a last resort. The fact is, peak engine performance and efficiency depend on adequate fuel pressure and volume from idle to peak horsepower. Diagnosing a fuel delivery system by considering pressure or volume alone can be misleading and unreliable at best, especially if testing is not performed at peak engine output when its volume requirement is greatest. The Mityvac FST Pro Fuel System Tester is the only on-car diagnostic tool that allows a technician to simultaneously observe values for both pressure and volume while simulating peak engine requirements. This video demonstrates the proper application of the Mityvac FST Pro to achieve the most accurate and reliable diagnosis of a vehicle's fuel delivery system. For the purpose of fuel delivery diagnostics, it's critical to determine if the fuel delivery system is return or returnless, as this will greatly impact the test procedure and corresponding results. On return fuel systems, all of the fuel coming out of the fuel pump goes into the engine. The engine draws what it needs from the continuous supply, and the rest is returned to the fuel tank. Return fuel systems will have two fuel lines going to the fuel rail, one for fuel going in and one for fuel going out. On a returnless fuel system, the only fuel pumped to the engine is what it actually uses. Excess fuel coming from the pump is bypassed either in or just outside the tank. Returnless fuel systems will have only one fuel line going into the fuel rail. Some manufacturers, including Ford, use a pressure sensor in the fuel rail to vary the speed of the fuel pump. These systems should be tested using the same method as a standard returnless system. Multiple speed fuel pumps are an additional variable that must be taken into consideration prior to testing. Some vehicles vary the fuel pump speed depending on engine requirements. In the case of a multiple speed fuel pump, follow the vehicle manufacturer's procedure to switch the fuel pump to its highest speed prior to testing. Once you've determined the type of fuel delivery system, follow the FST user's manual to properly install the fuel system tester. Be sure to note all safety precautions and always wear safety glasses. The key to determining whether a fuel delivery system is failing is to test it at peak engine output, because that is when it's under its greatest demand. To do this, you will need to know the vehicle manufacturer's specification for fuel pressure and the approximate volume of fuel the engine requires at peak output. The idle fuel pressure specification can be found in most service or repair manuals. The maximum fuel volume requirement can be determined using the maximum engine fuel volume requirements chart in the back of the FST user's manual, or it can be calculated using the maximum fuel flow formula found on the AASA Fuel Pump Manufacturers Council website at fuelpumpinfo.org. With the Mityvac fuel system tester connected and the connections properly tested, start the engine and allow it to idle. First, observe the fuel for contamination and air bubbles as it flows through the clear flow tube in the flow meter. If the fuel is discolored or appears contaminated, have it chemically checked and/or drain and thoroughly clean or replace the fuel tank before continuing. Expect to see air bubbles when you first start the vehicle, as air is purged from the tester and fuel line, but it is not normal to see them once the system is clear. The continued presence of air bubbles in the fuel stream is an indication of a severe restriction, typically at the fuel pump inlet strainer. Keeping this in mind, watch for further evidence of blockage as you continue testing. On return fuel systems, at idle, the pressure gauge will indicate the fuel pressure in the system. Make note of this value. Next, note the volume of fuel by reading across the top of the float on the FST flow meter and comparing it to the adjacent scale. Because the fuel pump operates at a constant output and all of the fuel must pass through the fuel rail, diagnosing the performance of a return type fuel system is very straightforward if you know the pressure and volume at the rail. In fact, on a return system, the test values for pressure and volume at idle represent the peak output of the fuel delivery system. Start by comparing the test value for idle pressure to the manufacturer's pressure specification. Is it normal, low, or high? Next, compare the test value for idle volume to the engine's maximum volume requirement you looked up earlier. If idle pressure is normal and idle volume meets or exceeds the engine's maximum requirement, the fuel delivery system is capable of performing to meet the engine's requirements from idle to peak output. However, if the pressure is out of specification and/or the volume is below the maximum requirement of the engine, this would indicate a malfunction in the fuel delivery system. While a performance test will determine if there is a malfunction, additional testing should be performed to pinpoint the cause of the malfunction and support the final diagnosis. The first test is to determine the maximum pressure the pump can produce when all flow is restricted. This is called a deadhead test. Performing a deadhead test will completely restrict the fuel flow, so be prepared to execute it quickly to prevent damage to the fuel pump. Locate the knob for the flow control valve on the side of the FST and rotate it 90 degrees clockwise from the open position to the closed position. Quickly note the value for peak pressure indicated on the pressure gauge and then return the valve to the open position. This completes the deadhead test. The second test is to determine the peak volume of the pump when there is no restriction to flow. This is called the bypass test because the volume is measured when the fuel flow is bypassing the pressure regulator. To perform a bypass test, turn the flow control knob from the open position 180 degrees clockwise to the bypass position. You will notice the fuel flowing from the bypass port located on the side of the tester above the flow control knob. While in the bypass mode, note the peak flow by reading across the top of the float on the FST flow meter. After you've recorded this volume, return the knob to the open position. If the vehicle stalls during this test, simply return the knob to the open position and restart. Performing a deadhead test and bypass test in addition to the original performance test will yield values for idle pressure, idle volume, peak pressure, and peak flow for the vehicle. List these values out as they will all be taken into consideration when making a final diagnosis. When performing the deadhead test, it is normal for the pressure to peak at least 50% higher than the manufacturer's pressure specification. If it can't achieve this output, then consider the value for peak pressure to be low. When performing the bypass test for peak flow, it is normal for the volume to reach over 0.7 gallons per minute. If it doesn't, consider the value for peak flow to be low. Using these criteria, indicate on your list of test values whether each is low, normal, or high.